Evolution of our planet began billions of years ago, when the surface was a sea of red-hot magma. It took millions of years for this molten rock to cool, eventually hardening into a landscape dominated by sterile mineral silicates. Today, those same minerals fuel a biosphere of dense forests and global agriculture. But plants cannot extract nutrition directly from solid stone. There is a missing link between the sterile minerals of the crust and the living organisms that depend on them. We call that link soil. It is a dynamic, multi-layered system that converts raw geological material into a medium capable of supporting the entire food chain. Despite how common it seems, soil is incredibly slow to produce. Depending on the local climate and parent material, it can take anywhere from 200 to 1,200 years to form a single inch of fertile topsoil. This makes soil a slow-motion geological and biological masterpiece, one that is constantly evolving through two distinct phases of transformation. According to this flowchart of soil genesis, the first step is a phase of destruction. Scientists call this weathering, the breakdown of solid rocks and minerals into smaller fragments. Physical weathering relies on mechanical force. When water seeps into rock crevices and freezes, it expands with enough power to fracture the stone. Constant wind friction and the abrasive grinding of glaciers further disintegrate these fragments into even smaller particles. Simultaneously, chemical weathering begins. Water and atmospheric gases trigger reactions like carbonation and oxidation, which dissolve and soften the rock. This process transforms solid minerals into a loose, unconsolidated material called regolith. This destructive phase is necessary to create a raw, mineral-rich canvas for the next stage of creation. Weathered material doesn't always stay where it was formed. We distinguish between residual soils, developing in place, and transported soils, relocated by natural forces. Moving water creates alluvial deposits, while wind generates aeolian dunes. The transport mode dictates particle shape. Whether a soil remains at its site of origin or travels miles down a riverbed determines its baseline mineral blueprint. This leads to stage 2, pedogenesis. This is the biological phase where life enters the equation to refine the weathered minerals. Microbes, fungi, and plant roots invade the regolith, secreting organic acids that further break down the mineral matter, transforming it into a dynamic system that can store energy and support life. Two critical processes occur here. Humification converts decaying plant and animal matter into dark, rich humus. Then, through mineralization, saprotrophs release organically bound nutrients into the inorganic forms that plants actually consume. Pedogenesis is the final step in the transformation, turning a sterile pile of rock debris into a living, self-sustaining ecosystem. The final result is dictated by 5 factors: climate, living organisms, topography, the original parent material, and time. Over decades of interaction, these factors naturally sort the material into distinct horizontal layers. This vertical section is called a soil profile. It begins at the solid bedrock, or R horizon, and moves up through the C, B, E, and A layers, finally reaching the organic O horizon at the surface. A mature soil profile acts as a historical barcode, recording thousands of years of geological and biological activity in a single vertical column. In its ideal state, healthy soil is a very specific mixture. It is typically 45% mineral matter and 5% organic matter. Surprisingly, a full 50% of that volume is empty pore space. This space is split evenly between the water and air necessary for root respiration and nutrient transport. Soil is not solid ground. It is a highly balanced, breathable network designed to facilitate the growth of life. It takes nature thousands of years to engineer this delicate profile. Yet, through erosion and human carelessness, that same inch of topsoil can be lost in a matter of years. Understanding the dual process of destruction and creation that forms our soil is the first step in protecting it. Our entire existence relies on preserving this fragile, irreplaceable resource.